Now come to the next question in exercise 5.1, question number 23. Question number 23. Find all points of discontinuity of f where f of x is equal to sin x by x if x is less than 0, and f of x is equal to x plus 1 if x is greater than or equal to 0. If you observe the given function, here they asked the points of discontinuity. Okay, my dear children, first understand the question clearly. If you observe the function here, the function is defined at x is equal to 0 left side and right side. So at left side, f of x is defined as sin x by x. The right side of 0, it is defined as f of x is equal to x plus 1. You know, in this case, if a function is defined like this, left side and right side, we have to find left hand limit and right hand limit. After that, we check that the continuity of the function. Okay, my dear children? Right. Now we are going to find left hand limit of f at x is equal to 0 and right hand limit of f at x is equal to 0. Okay, my dear children? Right. As x tends to 0 minus limit f of x is equal to, as x tends to 0 limit sin x by x. Instead of here f of x, in the place of f of x, I wrote sin x by x, because as x tends to 0 means x is less than 0, x values are less than 0. Then f is defined as f of x is equal to sin x. That is why in the place of f of x, I wrote here sin x by x. Understood this step, my dear children? Right. Now we have to find the limit of this function. If you observe this function, it is a standard limit. You know, as x tends to 0, limit sin x by x is 1. Here we don't go to the method of substitution here because it is a standard limit. So its limit value is 1. Understood this step, my dear children? Right. Now come to the right hand limit of f at x is equal to 0. So as x tends to 0 plus limit f of x is equal to, as x tends to 0, limit x plus 1, because as x tends to 0 plus means x is greater than 0. X values are greater than 0. In that case, f is defined as f of x is equal to x plus 1. That is why in the place of f of x, I wrote here x plus 1. Understood this step, my dear children? Right. Now we are going to find the limit of this function at x is equal to 0 by the method of substitution. So in the place of x, we substitute 0. X is equal to 0. We put x is equal to 0. So 0 plus 1. What will you get here? 1. So this is the right hand limit of f at x is equal to 0. So by observing these two limits, they are equal. Here as x tends to 0 minus limit f of x is equal to as x tends to 0 plus limit f of x, that is equal to 1. Both are equal. Both limits are equal. And also we find the function value at 0. F of 0 is equal to 0 plus 1 because f of x is defined as x plus 1 if x is greater than or equal to 0. So we are finding the function value at x is equal to 0. What will you get here? 1. Understood this step, my dear children? Right. So if you observe here, this value, limit, left hand limit, right hand limit and function value at x is equal to 0, all these are equal. Okay, my dear children? Then what can you say that f is continuous at x is equal to 0? Okay, my dear children? Right. Therefore, f is continuous at x is equal to 0. Therefore, finally we conclude that f is continuous at all points, and therefore f is not discontinuous at any point. Understood, my dear children? Right. Now come to the question number 24. Question number 24. Determine if f defined by f of x is equal to x into sin 1 by x if x is not equal to 0, and f of x is equal to 0 if x is equal to 0 is a continuous function. We have to check whether this function is a continuous function or not. Understood the question, my dear children? Right. Now we are going to find the limit of this function as x tends to 0, limit x into sine 1 by x. Here we know that minus 1 less than or equal to sine 1 by x is less than or equal to 1, because sine function value lies between minus 1 and 1. The range of the sine function, you know, close interval minus 1 comma 1. So we wrote this step. Understood this step, my dear children? Right. Now I am multiplying this inequation throughout by x. So then it implies we get minus x less than or equal to x into sine 1 by x less than or equal to x. I multiplied this entire inequation by x. Every term is multiplied on every side. Understood this step, my dear children? Now I am applying the limit x tends to 0. So this implies as x tends to 0, limit minus x less than or equal to as x tends to 0, limit x into sine 1 by x less than or equal to as x tends to 0, limit x. Understood this step, my dear children? Right. Now we can find limit of this function directly by the method of substitution, and we can find here also the limit of that function by the method of substitution. Means we put x is equal to 0, then we get here 0 less than or equal to as x tends to 0, limit x into sine 1 by x less than or equal to, here also we get to 0. So the limit of this function lies between 0 and 0. Is there any number lies between 0 and 0? No, 0 only. So therefore as x tends to 0, limit x into sine 1 by x is equal to 0. Understood this step, my dear children? Right. Now f of 0 is equal to 0, because f of x is equal to 0 if x is equal to 0. Okay, my dear children? Understood this step, my dear children? Here as x tends to 0, limit f of x is equal to f of 0. Limit of the function at x is equal to 0 and the function value at x is equal to 0, both are equal. Therefore what can you conclude? F is continuous at x is equal to 0. Understood this step, my dear children? Right. Now come to the question number 26. Find the value of k so that the function f defined by f of x is equal to k into cos x by pi minus 2x if x is not equal to pi by 2, and f of x is equal to 3 if x is equal to pi by 2 is continuous at x is equal to pi by 2. If this function f is continuous at x is equal to pi by 2, we had to find the value of k. Understood the question, my dear children? Right. Now let us find the limit as x tends to pi by 2, limit k into cos x by pi minus 2x. We have to find the limit of this function as x tends to pi by 2. Okay, my dear children? So as x tends to pi by 2, k into cos x by pi minus 2x, that is equal to as x tends to 0, limit k into cos of pi by 2 minus x by pi minus 2 of pi by 2 minus x, because there is a property in limits. As x tends to a, limit f of x is equal to as x tends to 0. In the place of a we can write here 0, and in the place of x in the function we can write a minus x. Here a means pi by 2, so in the place of a we wrote 0, and in the place of x here and here we are writing pi by 2 minus x. Understood this step, my dear children? Right. Now in the numerator as x tends to 0, limit k into here in the numerator we get sin x, because cos pi by 2 minus x is equal to sin x. From trigonometry you can find, you know this one, by pi minus pi plus 2x. In the denominator we get these terms. Now pi minus pi gets cancelled, then we get as x tends to 0, limit k into sin x by 2x in the denominator. Understood this step, my dear children? Right. Now In this function, k by 2 is a numerical coefficient. We can write it outside. So k by 2 into, as x tends to 0, limit sin x by x. Understood this step, my dear children? Right. That is equal to k by 2 into, the limit of this function is 1 because it is a standard limit. As x tends to 0, limit sin x by x is equal to 1. This is a standard limit. So we wrote here 1. Understood this step, my dear children? That is equal to k by 2. By simplifying these two, we get to here k by 2. And also given that f of pi by 2 is equal to 3, because f is defined as f of x is equal to 3 if x is equal to pi by 2. It means the function value at x is equal to pi by 2 is equal to 3. And also given that f is continuous at x is equal to pi by 2. Then what can you say? The limit and the function value at x is equal to pi by 2 are equal. Okay, my dear children. So we equate the two values to find the value of k. Okay, my dear children. Right. So we can write this equation as x tends to pi by 2, limit f of x is equal to f of pi by 2, because f is continuous at x is equal to pi by 2. So its limit value at x is equal to pi by 2 and the function value at x is equal to pi by 2. Both are equal. So we equating the two values. This implies we got here the limit of this function is k by 2 is equal to f of pi by 2 is equal to 3. Okay, my children. Now we simplify this equation. We solve this equation. For finding the value of k. This implies k equal to 3 into, if we are sending this 2 to RHS, it becomes into 2. So k is equal to 3 into 2. Understood this step, my dear children? Right. This implies k is equal to 6, which is the required value of k. Okay, my dear children? Right.